Hello viewers, welcome back to series of operating system lectures. In previous lectures, we have already discussed the introduction to OS, basics of OS, and recent lecture we have covered computer system architecture. Now in this lecture, we will understand the operating system structure. In operating system structure, an operating system which provides an environment for the execution of the program, and it makes a certain service available to the programs and to the user of those programs. The specific service provided, of course, the different from one operating system to another, but we can identify the common classes in this lecture. So operating system which provides the environment within which the programs are executed. That is the main definition of this operating system structure. So operating system structure provides an environment where the execution of the program take place. Okay. Now here what happens when it makes a certain service available to the program and the user of those programs, right? They may execute their programs and they may use the services, what services this operating system structure provides. In the operating system structure, we will be having multiprogramming and multitasking. With the help of multiprogramming and multitasking, we can able to perform a specific services, and the specific services are provided to the user and the programs. Now let us understand first of all the multiprogramming. Multiprogramming is a technique, right? It is a technique, and this multiprogramming that allows the multiple programs to run on a single CPU at the same time. One of the most important aspect of operating system is the ability to execute multiple program at a time. A single user cannot in general keep either the CPU busy or the IO device busy at all times, not both. CPU cannot be busy at all the times. So therefore what we are saying, when we have the multiprogramming technique which allows us the multiple programs to run on a single CPU at the same time, means either the CPU or IO device busy at all times, means all the times our CPU and IO devices will busy, which increases the CPU utilization by organizing the jobs. Job means the code and data, so that the CPU always has one to execute, means the CPU will not be idle, it will be always busy. So multiprogramming which increases the CPU utilization by organizing the jobs. The operating system keeps several jobs in a memory simultaneously. Now you can see there is a job pool, right? So job pool is having n number of jobs, say job 1 2 3 4 5 6 7. So total we have 7 jobs in job pool. So what happens when we have number of jobs, the job pool is created which contains all the jobs that enters the system, and since the number of jobs that can be kept simultaneously in the memory is usually smaller than the number of jobs that can be kept in the job pool, the operating system then picks the jobs from this job pool. The operating system picks the jobs from the job pool because a memory is limited. You can see 512 MB. M means MB. Now therefore the operating system picks and begins to execute one of the job in the memory. Eventually the jobs may have to wait for some tasks such as IO operation to complete. So here what we are doing here, we are just taking some of the jobs from the job pool to the memory, because memory is limited, right? We are having n number of jobs in the job pool, but at a time we cannot allocate the memory to all the jobs. So hence the operating system choose some of the jobs from the job pool to the memory. Okay, so that we can keep our CPU busy at all the time. One of the job, assume that the job 1 has completed its CPU burst. Now it requires the IO device to perform IO operations. So if it goes for the IO operation, the next the CPU is allocated to the job 2, and after the job 2, the next job 3 will allocate the CPU, job 4 will allocate the CPU, and so on. After finishing the IO operation, when the job 1 returns back, again it will get the CPU, right? It will get the CPU. So this is how this multiprogramming works, right? So in multiprogramming system, which provides the environment in which the various system resources like CPU, memory, peripheral devices such as IO devices, etc. are utilized effectively, because we can keep CPU busy all the time, we can keep IO devices busy all the time, we can use the memory, and we can keep busy all the time this memory also, but they do not provide for user interaction with some computer. So what is the meaning of this? Do not provide for user interaction, right? Do not provide the user interaction means, which, see, when the CPU, memory, peripheral devices are utilized effectively, but they do not provide for user interaction with computer system. So in multiprogramming, when job pool is created, all the jobs are submitted at a time to the memory. So operating system will choose some of the job from the job pool and allocate the memory. All the resources have been used, right? IO operations are provided, but user cannot interact with the jobs, right? So therefore the meaning of this, they do not provide for user interaction, means in multiprogramming you can perform multiple programs can execute at a time in the CPU, right, by providing the time quantum and using the round robin scheduling, but user cannot interact with the processes at all the time. That is the meaning of this. I will clarify the meaning of this sentence, right? Do not provide a user interaction means user cannot interact with all the jobs which he or she has submitted to the operating system already. Okay, so let me tell you one of the example, like a lawyer does not work for only one client at a time, right? He works for number of clients. If assume that the case is in waiting to go for the trial, then how he has to type a paper or prepare for the next case, and lawyer can work for another case. If he has enough clients, the lawyer will never be idle for lack of work. He will keep on working all the time. He will busy with all the cases. So similarly, a CPU will always busy with one or other process, because the number of jobs are already entered into the memory, so that we can get more CPU utilization in the multiprogramming. programming. So therefore multi-programming system provides the environment where we can work continuously and we can utilize all the system resources effectively. Okay, but user cannot interact with all the times. Why? Because there is a concept called time sharing. In the time sharing, all the time user can actively involve with the processes and involved with the computer. Now that is the second point. Okay, third point. Before I come to third point, let's understand the time sharing. Multitasking. Task means what? Work, right? Work. So time sharing or multitasking. So time is shared among the users. So CPU executes multiple jobs by switching among them. Switching occurs so frequently that user can interact with each program while it is running. Means it is so frequently switching from one process to another process, which CPU is so fast that in millisecond it is working and the jobs are changing so frequently, so that even though user can interact with each of the program while it is running. And also time sharing required an interactive computer system. Interactive computer system is each of the user can interact with their jobs, with their processes, which provides the direct communication between the user and the system. But in previous slide, there is a multi-programming environment where we can utilize all the system resources very effectively, but they do not provide means the resources will not provide a user interaction with the computer. Means user cannot interact with the computer while multi-programming is performed, right? Because already we have submitted n number of jobs by creating a job pool. When the job pool is created, the operating system picks the job from the job pool to the memory and executes it, right? Executes it, and after completion of some of the jobs from the memory, it will release that memory space and allocates the new jobs to the memory. But it doesn't provide the interactive system facility. User cannot be an interactive with all the jobs, where here the user is able to have the direct communication with the system. Let us understand by the example also. Okay. For example, here we have the diagram. Assume that a CPU is having n number of users. So we have 6 users in this example, right? This is the active state, ready state, right? CPU is so fast that it works in millisecond and nanosecond, so that each user thinks that this system is allocated to them only, and this system is dedicated to them. So user 1 thinks that this system is for me, user 2 thinks system is for me, user 3 thinks the same, 4 thinks the same, 5 thinks the same, 6 thinks the same. But the CPU scheduling and multi-programming to provide each user with a small portion of time shared computer. Means every user will get a small portion of time of the CPU, which is called time quantum or a time slice of the CPU, so that they are working in this time quantum and it is so fast, so that each user thinks that the entire system is allocated to them. That is the meaning of this third point. Okay. So time sharing requires an interactive computer system. Interactive computer system which provides a direct communication between user and the system. And also time shared operating system allows many to share the computer simultaneously. So there is one CPU and the 6 users are using this computer. This is called the interactive computer system which provides the direct communication between user and the system. Okay, and here the response time should be always less. Okay, so time shared operating systems allows many users to use the CPU, and it is used by all the users because of the CPU scheduling and multiprogramming. Okay, so each user has at least one separate program in memory, means all the 6 users are having a separate memory for executing at least one program, right? One program. Now a program loaded in a memory and executing is called process. So what is mean by process? A program loaded into memory and executing in a memory is called process. When process execute, it typically executes for only short time before it either finishes or need to perform IO operation. So whatever the slot is allocated, so in that slot is typically execute for a short time before either it finish in this given time or it will go for IO operation so that other process can occupy the CPU. So in this fashion the interactive work will take place between all the 6 users. So this is how the time sharing and multiprogramming require for several jobs to keep simultaneously in the memory to perform the work. Hope you understood this concept. So thank you for watching. Like, share and subscribe.